Okay, here's our test B video. So if you need to pause before you do all these questions, that would be good. Okay, questions 1 and 2. State whether the following numbers are divisible by 2, 3, 5, 6, 9, and 10. Circle the ones that are divisible. So pause the video, do problems 1 and 2 real quick, and then when you're done, restart your video. Okay, hopefully you've done these problems, so I'm just going to go through these. 2 is if it's even. 5 is not an even number, so I'm going to cross off 2. 3, remember that's a sum of the digits, so I add them up and I get 15. Since 3 goes into 15, 465 is divisible by 3. 5, I look at the last digit, that is 5. Since 5 goes into 5, that is divisible by 5. 6, I look at 2 and 3. Since I've only circled 3 and not 2, 6 does not work. For 9, I look at that 15 again. 9 does not go into 15, so I cross off 9. 10, I look at that last digit. It is 5, not 0, so I cross it off. So my answers are 3 and 5. Okay, for problem 2, I'm going to go through them. For 2, I look at the last digit. It's a 0. That's an even number, so I circle 2. For 3, I add them up. 8 plus 9 plus 1 plus 0 equals 18. Remember, only 3 and 9 use this rule. That is 3, so I circle 3. It ends in 0, so the rule for 5 is ending in 0 or 5, so 5 is a yes. For 6, I've circled 2 and 3, so I circle 6. For 9, I look at that 18 again. 9 goes in 18, so it's divisible by 9. And because it ends in 0, it's divisible by 10, so it is all of them. Okay, that's 1 and 2. Problems 3 and 4. Pause it and answer these real quick, and then press play when you're done. Okay. So for 53, is that prime or composite? 53 is prime. Why? It only has 2 factors. 1 and 53. Okay, it only has 2 factors, 1 and 53. Okay, 87, this is composite. Okay, why is this composite? Well, it has 3 or more factors. And you might be thinking, what is that third factor? Well, add them up. 8 plus 7 equals 15. 3 goes into 15, which means 3 goes into 87. Okay, so you got to use your divisibility rules to help you. Okay, I'm going to move on to 5 and 6. For problems 5 and 6, we're going to find the prime factorization. So please pause and do those real quick. Okay, hopefully you're done with these. If not, pause right now. 110, I'm going to break this up into 10 times 11. 10 times 11 is 110. 11 is prime, so I circle it. 10 is 2 times 5. Those are both prime, I circle them. So it's 2 times 5 times 11. Okay. For 300, I'm going to do 3 times 100. 3 is prime. I'm going to circle it. For 100, I'm going to do 10 times 10. They're both composite. 10 is 2 times 5. And this 10 is 2 times 5. So my answer is 2 times 2 times 3 times 5 times 5. Okay. For number 7 and 8, or for number 7, we're going to find the GCF. If you need to pause, go ahead. Okay, hopefully you've paused and done these problems. If not, do that now. For 60, I'm going to write out the prime factorization of each. So for 60, that's going to be 2 times 2 times 3 times 5. For 36, that's going to be 2 times 2 times 3 times 3. I look to see what they have in common. They have a 2 in common. They have another 2 in common. And they have a 3 in common. They have 2 2's in common and a 3. Multiply them and I get 12. So the GCF is 12. Okay, number 8. Pause if you need to do number 8 and pause it real quick. Okay, hopefully you've paused it and did this. Again, I'm going to list them out. 15 is 3 times 5. 12 is 2 times 2 times 3. They have a 3 in common. And then I multiply what is left over. 5, a 2, and a 2. When I do that, I am going to get 15 times 2 is 30 times 2 is 60. So they have an LCM of 60. Alright, moving on to problem 9. In problem 9, they have a product of 2 numbers is the LCM. What can you say about the GCF? Well, the only way that you can multiply 2 numbers to get the LCM is if the GCF is equal to 1, which means, what can you say about the numbers? They are relatively prime. Okay, so either one of those would be an explanation. Remember, you can only multiply them to find the LCM if the GCF is 1 or the numbers are relatively prime. That's the same thing. Okay, I'm going to move on to the next page. Alright, in problem 10, please pause this and answer number 10 real quick. Okay, hopefully you paused this and filled in the statement. The GCF of two numbers is never the greatest number. The GCF has to be less than the numbers. Okay, so a factor can't be more than a number, which means it can't be more than the lesser number, which means it can't be the greater number. Okay? Alright, number 11, error analysis. Please find my error analysis and finding the GCF of 20 and 30. Okay, hopefully you found that by now. If not, pause. The error of mine is, yes, 2 is a factor of 20 and 30, which makes it a common factor, but it's not the greatest common factor. The greatest common factor is actually, if I write these out real quick, so 20 is going to be 2 times 2 times 5, and 30 is going to be 3 times 2 times 5. The greatest common factor is going to be the 2's and the 5's. 2 times 5 equals 10. So the greatest common factor is going to be 10. So what's my mistake? I found a common factor, but not the greatest common factor. Okay, so I found a common factor, but you gotta be careful. It doesn't mean it's the greatest just because you find a common factor. Okay, number 12. Please pause and do number 12 about the blinking lights. Okay, this is an LCM problem. Okay, how many seconds until they blink at the same time again? So that's in the future. Think of the future as your multiples. So I'm going to do 3 is 3, 5 is 5, nothing in common, so I do 3 times 5. So that's 15 seconds. So they will blink every 15 seconds. Okay? Moving on to 13. Please pause and work on problem 13 real quick. Okay, hopefully you're done with working on problem 13. This is what is the greatest number of kits that Mandy can make. So I'm going to, that's a GCF problem. Greatest number left that you can make is a GCF problem. So I'm going to do the GCF of 18 and 27. 18 is 2 times 3 times 3. 27 is 3 times 3 times 3. What do they have in common? They have 2 3's in common. You multiply those 2 3's and you get 9. So your answer is 9 kits. What's the greatest number of kits that Mandy can make? 9 kits. Do not forget your label on these. Okay, I'm going to move on to problem 14. Okay, work on problem 14. Please pause it and work on it really quick. Okay, hopefully you're done. We're running laps around how many minutes till they'll next pass each other. So that's in the future, so that's going to be an LCM problem. So I'm going to do the LCM of 8 and 12. So 8 is 2 times 2 times 2. 12 is 2 times 2 times 3. Okay, and then you are going to find out what they have in common. They have a 2 in common. They have another 2 in common. So that's 2 times 2. And then you multiply what is left over times 2 times 3. Okay, so this is what they had in common, the first 2's. And then times what's left over for LCM. And when you multiply those, you are going to get 24. So in 24 minutes, they will meet up again. Okay, I'm going to move on to problem 15. We're going to pause this and do problem 15 real quick. Okay, again, this is the greatest number of groups that can be made, so that's a GCF problem. So I'm going to do 45, which is going to be 3 times 3 times 5, and I'm going to do 30, which is going to be 2 times 3 times 5. Since this is greatest common factor, I'm going to circle the 3's and the 5's. 3 times 5 is 15, so that is the greatest common factor, so we can get 15 groups. Okay? Now, next question is how many boys and how many girls. So I'm going to do the girls. It's 45 divided by 15, which is 3 girls. And I'm going to do the 30 divided by 15, which is 2 boys. So there's going to be 15 groups, 3 girls, and 2 boys. Okay? So you need to work on those. If you need to go back and watch any of them, go ahead. Otherwise, have a great night.